Hey guys, this looks like a fun one. We're given two semicircles inside of a larger semicircle. Now we're given this red distance perpendicular to here is equal to 2. And it's asking, what is this shaded area? This is day 10 of the 2025 Advent calendar. For the month of December, we're going to try to solve 31 Katrina Ag puzzles in 31 days. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. Let's label the diameter of this semicircle 2x and the diameter of this semicircle 2y. The reason I chose 2 for each of these is now we know the radius of this one is equal to x and the radius of this one is equal to y. Does that make sense why? And we can also express the diameter of the larger semicircle as 2x plus 2y. And that means that the radius would be equal to half of that, or x plus y. So if we find the center of this semicircle and draw this radius, we can label that as x plus y. And now we can write a formula for the shaded area. It's going to be the area of the large semicircle minus the area of this semicircle minus the area of this semicircle. So that'll be pi x plus 1 squared divided by 2 minus pi x squared divided by 2 minus pi y squared divided by 2. And now we can clean things up a little bit. Let's focus on the first term. This quantity x plus y squared can multiply out to give us x squared plus 2xy plus y squared. And then we can copy down everything else. And then next, let's distribute this pi to each of these terms. It'll be pi x squared divided by 2 plus pi 2xy divided by 2 plus pi y squared divided by 2. And then we can copy down everything else. And now to simplify this, let's rearrange things a little bit. For the positive pi y squared over 2 and the negative pi y squared over 2, these can cancel each other out. And then for the positive pi x squared over 2 and negative pi x squared over 2, these can also cancel each other out. And then for the first term, the 2 on top and the 2 on bottom can also cancel each other out. So now we have the area is equal to pi xy. This looks important. Let's put a box around it. Let's clean things up a little bit and decide what to do next. I'm thinking let's connect this point to here and let's connect this point to here. This will make an inscribed angle that stands on this diameter. That means this is a right angle. And then we're also given that this is perpendicular to this. So these are also right angles. And then we can label this side A and this side B. And now we have 3 right triangles. We can do the Pythagorean theorem 3 times. We can do the quantity 2x squared plus 2 squared is equal to a squared. We can do the quantity 2y squared plus 2 squared equals b squared. And we can do a squared plus b squared is equal to the quantity 2x plus 2y squared. And then we can play around with these. This squared will go to both of these, giving us 2 squared x squared. This 2 squared is equal to 4, and this 2 squared is equal to 4. And then the same thing down here. This squared can go to each of these, giving us 2 squared y squared. 2 squared is equal to 4, 2 squared is equal to 4. So now we have an a squared here and an a squared here, and a b squared here and a b squared here. Let's do some substitution. In the place of this a squared, let's plug in all of this. And in the place of the b squared, let's plug in all of this. Let's rearrange things a little bit, and 4 plus 4 is equal to 8. And then on the right-hand side, this squared is the same thing as this times itself. And then we can multiply all this out to give us 4x squared plus 8xy plus 4y squared. And now both sides of the equation contain a 4x squared, and they both contain a 4y squared. Let's subtract 4x squared and 4y squared from both sides of the equation. On the left-hand side, all of this will cancel out, leaving us with 8. And on the right-hand side, these will cancel and these will cancel, leaving us with 8xy. And now let's divide both sides by 8, and that'll give us 1 is equal to xy. And now we can find the area. In the place of this xy, let's plug in 1. And pi times 1 is equal to pi. Let's give it a label of square units, and it's already got a box. This is the answer to our question. In the given diagram, this shaded area is equal to pi square units. That's actually really cool. How exciting. And this is the question for day 11. We're given 3 equilateral triangles with side lengths of 12, and they stuck a semicircle inside of this right here. And it wants to know what is the area of the semicircle. This looks like it'll be a fun one. How exciting.